Hi everyone, in this video we are going to learn about hydrocarbons. So first thing which we are going to learn in this is the structural formula. So what do you mean by structural formula? So it is the representation of bonds when the carbon is bonded with itself or with hydrogen or with other elements. So how do we represent that? The organic compounds made up of carbon and other elements with carbon and other elements. So we are going to represent structural formula. So first, simplest one, which we have already discussed in our previous video, is methane. So methane has one carbon. Then we all know that carbon has tendency to form four bonds to complete its octet to attain stability. So carbon has four bonds with hydrogen. So the bonds, the lines which we have drawn here represent the covalent bond. And if you remember in our previous video, we have learnt about covalent bonding. So covalent bond is the bond formed by sharing of electrons to attain stability. Second hydrocarbon is ethane. So ethane means two carbon atoms. So you need to remember these till carbon number 10. So two carbon atoms. Now this carbon atom is already bonded with one carbon atom. So one bond is there already. So this carbon needs to form three more bonds with hydrogen to complete its octet. Similarly, this carbon, it is already bonded with this carbon atom. So it needs to form three more bonds with hydrogen to complete its octet. So this representation of showing bond between carbon and hydrogen, between carbon and carbon, is known as structural formula. Then we have propane. Propane has three carbon atoms linked together in a long chain. So we will see again this carbon, the first carbon is bonded with one carbon, this one. So this has to form three more bonds with hydrogen. What about this carbon? This carbon is bonded with the first carbon. If I number them like this. So second carbon is bonded with first carbon and third carbon. So two bonds are already there. So it will form two more bonds. Now what about this third carbon? So third carbon, it is already bonded with one carbon. So it has to form three bonds with hydrogen. So this is one way representation of structure formula. We'll go further and then we have butane. So butane means four carbon atoms bonded or linked together in a long chain. So again we will follow same thing. This carbon is bonded with one carbon, so it has to form three bonds. This is bonded with two carbon atoms, so it will form two bonds with hydrogen. This is bonded with two carbon atoms, so this will form two bonds with hydrogen. What about this carbon? It is one bond, so it has to form three bonds. So that's how we write structural formula of different compounds knowing the number of carbon atoms. So these are the things which we need to remember. So pent means 5. So first of all, you just write 5 carbon atoms this way and then put hydrogens. So this becomes very easy, and we call these formulas structural formula of hydrocarbons. Similarly, we have hexane. So as the name suggests, hex means 6 carbon. So we will write long chain of 6 carbon atoms this way, and then we will put hydrogen on each carbon. and so on. So we should know till decane. Decane means 4. So there is hexane, then heptane containing 7 carbon atoms, octane containing 8 carbon atoms. So 7, 6, I'm writing it in the bracket, octane 8, and there is nonane. Nonane means 9 and decane means 10. So you should practice them by writing carbons in the long chain linked with each other and then put the hydrogens depending on how many bonds carbon has to form with hydrogen. So that's how we write the structural formula of hydrocarbons. Then comes drawing alkane structure. So I'll move further. Drawing alkane structures. And in alkane, it is always single bond. So there is always single bond between carbon and carbon. That's why we call them alkane hydrocarbons, because they contain single bond. So we will study about them later in the next video. So first step is, how will we draw alkane structures in different ways? First is molecular formula. Then we will study about complete structural formula. Then we will study about condensed structural formula. Then bond line structure. Structural formula. So these are different ways to represent alkanes or hydrocarbons. So first is molecular formula. So as we all know that the general formula of alkane is CnH2n plus 2, where N is number of carbon atoms like 1, 2, 3 and so on. So if I write first structure, I'll go to the next slide. So we will do it. So molecular formula. As I said, alkane has general formula. This is the general formula of alkane. Please remember. So you should know this, where N represents number of carbon atoms. So if I have number of carbon atoms 1, so what will be the molecular formula? Or we write this way, C1H2 into 1 plus 2. So it becomes CH4. So this is your molecular formula of methane, because it contains 1 carbon atoms and 1 carbon atoms means meth. And it is an alkane, so that's why suffix is ane. Now, for this, if I want to write its structural formula. So structural formula means where we represent the bonds between carbon and hydrogen. So this is carbon and we are representing 4 bonds with 4 hydrogen. So this type of structure which we write, where we are showing the bonds between carbon and hydrogen, is known as structural formula. Then if I want to write its condensed formula. So in case of methane, condensed formula and molecular formula is same. So it is, you are not showing the bonds, but there are bonds between carbon and hydrogen. So just we write CH4. This is condensed formula. So I'll take other examples so that we can make you understand the differences between molecular formula, structural formula, and condensed formula. First, other example which I'll take is propane, for example. And you know that propane, prop means 3 carbon atoms. So I will write this. So what should be the molecular formula of propane? If we use the general formula, CnH2n plus 2. So N is 3 for propane. So it is C3H2 into 3 plus 2. So the formula becomes C3H8. So this is the molecular formula of propane. If I want to write its structural formula of propane, so what I'll do is I will write, because it contains 3 carbon atoms, so I will draw the structure like this. And because as I know that carbon forms 4 bonds with hydrogen and with itself, then, and you can just cross check it, there are 3 carbon atoms and count the hydrogen, 1 2 3 4 5 6 7 8. So this is following this molecular formula. So this is your structural formula of propane. Now I want to write its condensed. I don't want to show every time the bond between carbon and hydrogen. So instead of that, this structure can be written as CH3, right? This can be written as, there is bond CH3, CH2. There is bond between them CH3, or sometimes we just write CH3, CH2, CH3. So this is how we write the condensed formula of any hydrocarbon, where we are not showing the bonds between carbon and hydrogen. We are just writing them this way. Then the last one which we have is bond line structure, which we will do in our next video. Thank you so much.